Evening. So I've already done one video about this power supply circuit board. I just wanted to do this one. The bulk of it, the later parts of it, are just me in fast motion making or laying out almost the final layout for the board and changing my mind heaps of times. I'm still not happy with it. It's kind of silly in a way because it's such a simple circuit, but it had a few constraints so that I wanted to fit it into a certain place in the existing box. I wanted to have the regulator. I think it's called a LDO. It's not very clear. LD084. Yep, an LD084, which is, I wanted to use that at 5 amps. I wanted to make sure the electrolytic capacitors are a reasonable distance away so they don't get dried out by the heat. I also wanted to have, like, it's pretty simple, but I wanted to have it so it's in ranges so that I get a bit of reasonably precise control over the output voltage of the variable part. And that it's there's a bit more required because it's the upgrade to the power supply is to have two independent outputs, isolated outputs. I don't know why, but the transformer I use already has two separate 17 volt AC windings. And I was only using one of them, which seems a bit silly, but so it's kind of simple power supply. But the first part, so the latter part is just fast forwarded me going back and forward, laying out the board, changing it until I'm almost happy with it. But the first part, I just wanted to show a few of the things about KiCad and etc. that I learned while I was doing it. So the first thing is to do with the 5 amps. So if you, it's the wrong screen. So if I go to PCB with trace with calculator, you can probably find heaps of these. But so if I say 5 amps and at 2 ounces, so the trace in here, not an inner layer. I was getting that wrong. I was going by this number, not this. So 1.38 millimeter wide track at 2 ounces copper can carry 5 amps. But if you go to the JLCPCB ordering page, which is just, this is a company that I use. They're quite good. I've made quite a number of boards, much more complex ones than this. So for a board less than or equal to 100 by 100 millimeters, 2 layers with 1 ounce copper is $2. But if I use 2 ounces, it jumps to $19.40, so it's a massive jump. So I want 1 ounce. If I change to 1 ounce, I get a track width of 2.77 millimeters. And so I come back to the circuit, and if I make a track width of 2.77 millimeters, I just want to see. Now, the first time I did this, I was using the top figure, so I was thinking that the track was going to be 7 millimeters wide. So I may have solved a problem that didn't exist, but we'll see how practical So if I look at this, so I've put some tracks here which are 2.5, so it's not going to be too, it's probably possible. It's a bit embarrassing. So this is the output. So the 5 amp is the input to the regulator and the output. So this is the track from the input board connector into this screw, at the moment, this screw terminal. So if I clean up the whoops, all the tracks, refill, okay. So if I use this, so I want to go with this, it works. Okay, so it's not too bad. But still I don't like it much. It's not bad. It's gonna, for the purposes of the video, yeah, that would probably have been, yeah, it's not too bad. Is that 2.77? Oh, come on. Oh, no, it's not. Why are you not? Oh, I didn't check it. That's why. It's easy to forget. Hang on. Let's try that again. Shall we? No, I'm no expert at KiCad at all. Try this again. X. There, that's better. So I don't know about that. It's a bit... No, see, it doesn't want to. Now if I go there... No, you can't do it. So it does prove the point. So you can't put... So that the design rule says I want 5 amps in and out of this regulator. And I want that, so I need 2.77mm width of track, but you can't fit those. Now you could, I guess, just go to the other side. So you do a track half the width or almost, or 2mm and put one on each side, which is kind of what I do. But I thought, given, so, and you can also do stuff like, you can go here, you can go close. Oh, come on. You can go close to it like that. Oh, but it's really painful. And then as well go close to this one and then drop the track width to say 2.5. That's not right. I just did a stupid I don't know why it does that. I don't, there must be, again, I'm not an expert. 2.5, I think. No, it's still not right. No, you can't do it even at, no, you can't. So we've got a constraint. So what you can do is what I did in the end, whether it's rightly or wrongly. Is, now I hope this works. So there's a filled area on the back and front which is ground. That's okay. But let's say what I'm going to do is place a filled zone not what is it? V input net, both the front and the back, with a 1.5 millimeter spoke width, and I need to give it a priority of 2 or higher than 0. And if I do that, then that's the way to get it so that it effectively makes the enclosed zones fill in an isolated way from the outer zones. Otherwise they all join together if they're all the same priority. So now if I go to here, I hope this works, to there, so it kind of just makes a nice triangle. So now if I hopefully this works. Yes. So now there's a big thick copper. It's got thick, whatever they're called. I can't remember those connections. It's going to be a problem to solder though. But it's also on the back and the front. So that's all, so I can use 1 ounce copper and fit. So it just separates. So I do the same for this side as well. What's the other thing that I wanted to show? I think I've got almost all of it. The other thing, if we go back to the circuit. Whoa. So I wanted to change from these screw terminals because they require you to go in sideways, and then that means they have to be positioned a bit more carefully because you can't put them near capacitors or the edges of the board that are next to the case. So I just wanted to, so there was a struggle finding, so I usually use element 14, and I mean now it's sometimes quite difficult to navigate this thing. So can I find it? So because the problem is you've got to find what you've got to find in whatever supplier you use is something that, well, you don't have to, but to save time, it's good to find something that KiCad already has a picture of. So let me just check which one no, I can't find it out. Hang on. So I've just got another one on the board. Whoops. This. So it's a Molex. Oh, come on. It's that. A Molex. That's this. Now I found this on, so 396 5273. Okay, so that didn't work. 396 5273. Unless I typed that wrong. Is that right? Yeah. So, and well, what do we need? 527. I think 527302A. Now I'm getting confused which one I have to go back to. There. That. So what Okay, and it's not even listed. That's the problem. So the manufacturer part number is listed as something else. So it's now 5273028, also known as. So you got to be careful. So I picked this because you can plug from the top you can plug down vertically, and it's Molex. It's a good brand, and it's cheap. In single quantities, it's 38 cents, which is good. So if I now, what am I going to do? I'm going to change, I'm going to copy this. So to change the symbol, so I'm going to take it from whatever it was and put this. And then I'm going to update the PCB from the schematic. So now I have my nice, same as that one. And that means it's better. So I don't, so now you can push the I'm using hand movements, which is pointless. You can push the connector to the output down from the top rather than having to, because the board may be plugged, there's two displays and the output's just here, so that if you try to put the wires in sideways, it's possibly going to interfere. Anyway, but then I do the same procedure to then wire this up, like the same kind of, I can try, let me have a look. Let's have a look, ground. So if I edit, fill the zone, so I'm going to go to ground because it'll hit the ground. So then I can draw a place of filled zone from there on. I know it's C2 pad 1 and I want it on both sides, and I want to give it a priority of 2. Anything else? I don't think so. So then I go to there, to there, wait, to there. I don't really need it so much to the capacitor, but still, why not? No, I don't want to do that. And then if I fill all zones, I get a nice, oh, I forgot to do something. I forgot to change the width of these connections, which I do by doing that. So that's, what are they called? Thermal spokes, yes. It's to do with soldering. It's going to be, yeah. I'm regretting that I had a nice old Weller, which for all its faults, like it had expensive tips because they use some magnetic method to be temperature controlled, but it was good for soldering when for things like this where the copper tracks are big. This is going to be a problem, but I still want the good current carrying capacity. Yeah. So you can see that those copper, some people call them copper pores, I think, but they're separated, so they'll carry a big current, and they're separated from the ground planes. So there's ground planes on both sides, which is good to do because it saves. You want to etch as little copper as possible because it's just. I think it's better for the environment to do that. And the board will work better too. But it's not really critical for this board because there's no high frequencies on it. But anyway, I hope that is of some interest. And so I'll sign off here and leave you with the rest of my PCB laying out. Yes, but it's still not finished. So hopefully I'll finally ship this and send it off to be manufactured and show it. Be able to show it in the power supply once I've built the board, and hope it works. I haven't picked these resistors, by the way. They're all, I need to work out exactly, but at the moment it doesn't matter. I'll figure out what values they need to be. I'm just trying to think if I wanted to say anything else. Oh, I've got to put curves here. I like the curves around there. What else do we need? I probably should check to see if it needs diodes across. Sometimes when the older regulators, they would have a diode across here, so that when these capacitors discharged, the diode would carry the current back. They seem not to be specified for either of these regulators, so maybe it's not necessary. They're both, I think they're both low dropout, which is not really a requirement. They're so in the past I would have used an LM317 and a 7805, but so yeah, this is a 5-volt regulator. This is a fixed 5-volt regulator to drive the power for the voltage readout on the power supply. So yeah, the final power supply will have two of these boards in it. Anyway, I'll stop. Thanks for listening and watching.